Good morning, all of you. Myself, Jobin Joy, Assistant Professor, Providence College of Engineering, Department of Mechanical Engineering, Providence College of Engineering. Today, I will give you an idea about the generative design workspace in Fusion 360. So, before starting into the session, I will give you an idea about what is generative design. So generative design actually helps you to define a design problem. See, for example, if you have a design problem, there will be some goals, there will be some constraints. Okay, so you can define a design problem with goals, your goals, various constraints, etc. So this generative design generates set of designs, say n number of designs. You will get n number of designs based on your goals, based on your constraints, etc. And you can explore the set of designs and you can select the optimum design for the manufacturing, for final manufacturing. So which type of material, different types of materials, which type of manufacturing method you are using, what are the performance criteria, what about the functional requirement, etc., etc. So this is the simple definition of generative design. So the definition: define a design problem by goals, constraints, and this generative design will give you a set of designs and you can explore the set of designs and you can select the optimum one for manufacturing. So I will explain the process, the working of generative design workspace in Fusion 360 with the help of an example. Okay, it's a bracket. So first you have to create your model. Okay, so your model in this Fusion 360. So here I will take this sample design. So here click data panel. This is the data panel, and go to this. Here you can see samples, basic training samples, CAM samples, design samples, electronic samples, and here you can see the generative design samples. So I will double click on this generative design samples. So here you can see the first option is the outcomes, then ready to explore, ready to generate, and below that you can see the third one, that is the G bracket. Okay, it's a bracket. So when we are dealing with the aircraft systems or aircraft jet engines, this bracket will be a critical component in aircraft jet systems. That means the engine bracket. So the brackets actually support the weight of the engines without breaking or warping. So very, very important. So it's a critical component in aircraft jet engines, engine bracket. So it's a bracket. So I will double click on this GE bracket. So in the aircraft, in the aerospace parts, you know, what about the weight? See, weight should be reduced. So the main thing is we have to reduce the weight, or we have to reduce the mass. That is very, very important. Okay, if we are reducing the mass, what happens to the strength? Can I reduce the mass to a certain unlimited value? No, that's not possible. So that the weight should be, the mass should be optimal. Okay, so in the case of this aerospace parts, one important thing is the mass, minimization of mass or weight reduction is very, very important. At the same time, there is no compromise with strength as well as the performance. So this is an example of GE bracket. So you have to open this from this data panel, GE bracket. Then I will save this. Okay, I will save this. Then I will go to this generative design workspace. Okay, so I will go to generative design workspace. Yeah, here you can see this is the generative design workspace. Okay, and here you can see in the browser this generative model. So here this is the generative model, and under that you can see structural study. Okay, so these are the different options. So I will explain everything in detail. Okay, preserve geometry, obstacle geometry, etc., etc., etc. Okay, then what about the objectives, then manufacturing, and finally the load. Okay, so here first I will so once again I will go to this design. Yeah, so first you have to prepare your model. So here this is my model. Okay, so first you have to prepare the model. Okay, and then you have to open this in the generative design workspace. Then you can change this this units. Okay, so here in the browser tab, units custom, you have to click this. Okay, you can change the unit settings. So here this is the default unit set, that is the custom, then metric SI, then US inch. Okay, so I will select this US inch. Okay, here corresponding units are displayed here. Then I will click OK. So you have to first you have to open this your model in the generative design workspace. Then you have to change the unit. Okay, click here and you can change the unit. Now the unit is US inch. Then go to study, click study, and here study settings. Okay, click study settings. Okay, you have to adjust the resolution. Okay, so here course in the middle, this is the normal resolution and this is the fine. Okay, so you have to go with the normal resolution, because when you if you will give the resolution as fine, what happens is it will take too much time to generate the outcomes. Okay, so coarse means the result will be something poor. So you have to fix the resolution as normal. That means in between this coarse and fine. Okay, so you have to set the resolution as normal resolution. Okay, then I will click OK. Okay, or you can from here, from this study settings, you can select, or you can select from here, right click here. Okay, so you just right click here and then you can see study settings. Right click structural study 1 and right click here and you can see the study settings, or you can use the shortcut key. Okay, so here you can see the shortcut key is E. Okay, when you press the key E, the study settings is displayed in this in the screen. Okay, so the resolution is normal. Okay, then next is the, if you want to edit this model, you can go with this edit model option. Okay, you can edit this model. So in this model there is no editing, so I will go with my design space. Okay, so design space, in the design space you can here you can see that the first two options, preserve geometry as well as the obstacle geometry. What do you mean by preserve geometry? In generative design, some geometry you want to include, or some geometry exclude, include or exclude. Okay, some bodies or some components, some bodies you want to include in the design, or some you want to exclude from the design. Okay, so the design you are actually included in the final outcome, that is called a preserved geometry. That means there is no change when you generate the outcome. There is no change from the starting point to the end point. There will be no change. There will be no change. That geometry is called a preserved geometry. Obstacle geometry means that is actually, so when the outcome is generating, that shape or that geometry, that the shape of the geometry is actually changing. Okay, once you will see the outcome, then it will be very you can see the preserved geometry and obstacle geometry very clearly. Okay, so now you just think that preserved geometry, that means preserve, that means from the beginning to end of the generative design, there will be no change in that geometry. That is called a preserved geometry. Obstacle geometry means change. Okay, so this is called a design space. That means that is the design space. So some geometry there is no change, some geometry some change is there, shape change is there. Okay, so I will click this preserve geometry. Okay, so I will click this preserve geometry, and then so I will select this one. Okay, this body, this body, this body, and this body. Okay, so these four bodies I want to preserve. Okay, I will click OK. So here what happens, you can see that what is the color, what is the color of that preserved geometry? Green in color. Okay, when in the generative design you can see this preserved, this body is in green color, that represents these geometries are the preserved geometries. Okay, these four geometries are the preserved geometries. Okay, and also I want to preserve these two rings. Okay, this ring 1 1 and ring 2 1. Okay, so again I will go to design space, preserve geometry, click this. Okay, here you can see 1 2 3 4 5 1 6. So total 6 bodies. Okay, so total 6 bodies. Preserve geometry. Okay, so you can see what is the color. Color is green color. Then go to the obstacle geometry. Okay, so okay, so I will select this, all other, and then I will click OK. Okay, so here you can see what happens. Red color. Okay, so in the canvas you can see this green color represents the preserved geometry. That means there will be no change from the starting to the generation of the outcome. There will be no change in the four bodies and the 2 rings. That is total 6 bodies. No change. Okay, but the geometry you can use, you see in red in color, that is called an obstacle geometry. That means that geometry, that means that geometry is the shape is actually changing from the beginning to the generation of the outcomes. Okay, so green represents the preserved geometry, the red represents the obstacle geometry. I hope it's clear. Okay, then the next step is, okay, so here you can see, so here in the browser, just go here, and here you can see this is the preserved geometry. If you want to edit, okay, you just click this and you can edit this. Okay, or if you want to edit the obstacle geometry, click here, you can edit this obstacle geometry also. Click this arrow, you can see preserved geometry 6 bodies and the obstacle geometry 2 bodies. Here you can see. Okay, then next is so initially I have modeled this, and then I will go with this generative design workspace. Then I will change the unit system. Then I will change the resolution. Then if there is any editing you want, if you want to edit this model, you can go with edit model option and then go with the design space and then apply the preserve geometry as well as the obstacle geometry. Okay. Then next is the conditions. Next is the design conditions. So design conditions means whenever if there is a design problem, there will be some constraints, there will be some structural constraints, there will be some loads, etc. Okay, so here you have to give your conditions. Okay, what are the structural constraints, what are the structural loads, etc. You have to give the constraints, the loads, etc. Okay, that is in the design conditions. So I will click here this design conditions, structural constraints. Okay, then I will select this four body faces. Okay, and remember one important thing: you can give constraints to only the preserved geometry. That is important point. You can apply the structural constraints to the preserved geometries. Okay, so bodies 1, 2, 3, and 4. So the type is fixed, and the targets 4 faces, 1, 2, 3, 4, 4 faces, and all axes UX, UI, UZ, all total. That is type is actually fixed. Okay, so this is the constraint. Then I will click OK. Okay, so here you can see this log symbol. That means constrained these 4 bodies. Okay. Yeah. Okay, so here this is the constraints. Then next is you have to give the load. Okay, so I will click this structural load. Okay, then I will go with this model components. Then I will switch off the visibility of this pin. Okay, so I will select this inner face, these two inner face. Okay, and then this vector select, see direction type normal, then angle, and then vectors means what is the fx, what is the fy, and what is the fz. Okay, so here I will enter this fz as, say in this example I will enter this as 8000. Okay, then I will click OK. Okay, clear. Then then I will duplicate here. This is the load case 1. Then I will duplicate this load case 3 times. Okay, so I will right click here, and here you can see clone load case. So right click here and click clone load case 1, 2, and 3. That means I am duplicating this load case 1 3 times. So here you can see load case 2, load case 3, and load case 4. So 3 load cases are there. Load case 1, load case 2, load case 3, and load case 4. Then I will open this load case 2, then load, then I will edit here. Okay, so here you can see the same value, the FZ value is 8000. Okay, so I will change this FZ as 0 and this FY value as, say, minus 8500. Minus 8500. Okay, so that is load case 2. Then I will click OK. Okay, so load case 1, load case 2. Then I will go to load case 3 and edit this one. So load case 3, I will change this FZ as say 6357 FZ force, and this FY minus 7060 minus 7060. Okay, so this is load case 3. Okay, then load case 4 here. So here you can see load case 4. So I will delete this force. Okay, F4. What is F4? F4 means the FZ value is 8000. So I will right click here and delete this. Okay, so this is load case 4. Okay, then I will go to load, then I will select this. Okay, select this ring 1, then I will change this Fy value as minus 1400 pound force. Okay, click OK. Okay, so that is force 5. Then again I will go to this design conditions, structural loads. Okay, select this ring 2, and then I will go to this vectors x, y, z, and then this Fy value as 1004, positive 1400. Okay, so here force 5 minus 1400, then force 6 1400. Okay, okay, so I have applied loads. Okay, so I will select this here, load. Here FZ 8000 pound force. Then next is load case 2, this Fy minus 8500. Then here this is Fy minus 7060 and then FZ 6357. And finally load case 4, this has force 5 minus Fy minus 1400, force 6 1400. Okay, so I have applied the constraints as well as the loads. Okay, then I will switch on this thing. Yeah, clear. Then I will go with this criteria, design criteria. Okay, what is your objective? Okay, what is the objective to conduct this generative design? What is your objective? Okay, so I will click here objective. So as I already mentioned, in the case of aerospace parts, or in the case of aerospace applications, the weight will be minimum. The mass, you have to reduce the mass, you have to reduce the weight. Okay, so my main objective, what is my objective? My objective is either you can minimize the mass or the maximize the stiffness. Okay, so if you are giving the maximum stiffness, okay, you can give a target value, mass target. You can achieve, so you can input say any value. Okay, so you can achieve this target by maximizing the stiffness. Okay, so here I am using this minimize mass. Okay, so my objective is to minimize the mass with a safety factor. Okay, so here I am giving the safety factor of 2. Okay, factor of safety as 2. Okay, or you can give the maximum stiffness with what is the factor of safety and also the target mass. Okay, what is the mass, target, and the safety factor? So here I am using the first option, that is the minimize mass with a factor of safety of 2. Okay, Then I will click OK. Okay, so here in the browser, go with this objectives. Okay, so here you can see objectives. So here you can click here. You can see minimize mass with a safety factor 2. Okay. Okay. Then next is the what about the manufacturing? Okay. So what about the manufacturing? So this is my objective. Then what about the manufacturing? Is it an additive manufacturing, or is it a milling operation? Okay, or it's a 2-axis cutting or die casting, etc., etc. Okay. So here I am using the first option, that is the additive, that is the rapid prototyping 3D printing. Okay, or you can select milling operation or 2-axis cutting. Okay, then the die casting, etc. Okay, also you can include the cost estimation. What about the production volume, etc. So I will not enter any of these values. So I will use this additive option. Okay, the manufacturing method I will use is additive manufacturing. Okay, then I will click OK. So now so go to the browser, and here you can see manufacturing, and here you can see the additive option. Okay, then next is you have to select the materials. Okay, study materials. So here I am using 4 different materials. Okay, so go to materials. Okay, and then I will select the material. The first material is so 1 minute. Yeah. Close. Okay, so I will change this manufacturing into unrestricted also. Okay, then go to materials, study materials. Okay, so here you can see various. So I will delete this, and here yeah, I will use this material, stainless steel AISI 446. Okay, I will double click this. I will scroll this and paste here. So here you can see stainless steel AISI 446. Then next is next material, that is the stainless steel 440C. Okay, so AIS stainless steel AISI 446, stainless steel 440C. Then next is yeah, this one, steel AISI 1045390QT. Okay, okay, and the last material is yeah, titanium 6Al 4B. Okay, so here 4 materials: stainless steel AISI 446, stainless steel 440C, steel AISI 1045390QT, and titanium 6Al 4B. Okay, so I will close this. Then I will so here you can see the materials. You can see the 4 materials displayed here in the browser: stainless steel, okay, AISI 446, stainless steel 440C, then 1045390QT, and a titanium 674. Okay, so now everything is okay. So I have given all the I have defined my problem. So I have given the preserved geometry, obstacle geometry, various conditions, constraints, loads, okay, the different criteria, my objectives, manufacturing constraints, various study materials I have included. Then the next step is you can generate the outcome. Okay, so that is the next step, generate the outcome. Okay, so here, see, this is a cloud-based software, and here the generation of outcome actually need 33 cloud credits. Okay, so when I click this here, you can see if you want to generate the outcome, you can click here generate button, and you can click this generate button, and you can generate the outcomes, but that will take 33 cloud credits. Okay, so here in the go to data panel. In the data panel, you can see there is an option in the generative design samples. You can see ready to explore. That means they already generated the outcomes and save that outcomes into this folder. If you are interested, you can generate, no problem. Okay, so there the team already generated the outcomes and saved it into this folder, so you can explore it very easily. No need to click and generate this. Okay, so I will double click on this ready to explore option. Double click on this ready to explore option, and here you can see explore. Just check explore GE bracket. So here the third one, explore GE bracket. Double click here, explore GE bracket. Okay, so here you can see two tabs. Okay, one is GE bracket V1, and here the second one, this is explore GE bracket. Okay, so go to this explore option and this explore generative results. Click here, explore generative results. Okay, so here these are the outcomes. These are the generative design outcomes. So I already explained in the beginning what is generative design. Generative design, you are actually defining a design problem, and you are having some goals, various constraints, etc. So you are defining your problem very clearly, and this generative design will give you a set of designs. So here these are the set of designs based on your goals, based on your constraints. These are the set of designs. Okay, here you can see outcome 7, outcome 6, 5, etc., outcome 8, etc. So these are the outcomes, these are the set of designs. Okay, and you can explore all these designs. Okay, you can go with this all these designs, and you can select the optimum. You can select the optimum one. You can compare various designs. Okay, and you can explore the designs, and you can select the optimum one for the final manufacturing purpose. Okay, so that is the generative design. Okay, so here in the explore, here you can see in the left top, you can see there's an option that is called before that, here you can see in the left side, you can see 4 options: view, okay, thumbnail view, property view, scatter plot view, and table view. Okay, so this current view is called thumbnail view. So you can see the thumbnail view. If you want to see the properties view, click the second option. You can see the outcome. Say for example, this is outcome 7, and what about the mass? 1.592 pound mass. And this is outcome 6. What is the mass? 1.631. What is the this is outcome 5. What is the mass? 1.729. And its properties. Okay, its various properties. Okay, you can see you can by clicking this properties view, you can see this. And if you want to see the scatter plot view, okay, so this is the scatter plot view with, this is the minimum factor of safety, you can see this various different materials, 4 different materials, and this mass. Okay, so this is the scatter plot view, and finally the table view. Okay, this is the table view. Okay, these are the outcomes. 1 2 3 4 5 6 7 16 outcomes. Okay, here you can see the 16 outcomes and the processing status, the material using, then the manufacturing method. Okay, then the visual similarity, what about the cost, etc. Okay, volume, mass. So what is the mass? Then what about the stress? Then factor of safety. Okay, you can see what is the factor of safety. I'm given factor of safety as 2. Okay, and what about the displacement, maximum displacement? So these are the 4 view options: thumbnail view, properties view, scatter plot view, and table view. So I will click this thumbnail view. Once again, I will click this thumbnail view. And I will sort. So here you can sort your designs by selecting the processing status, then study, visual similarity, then recommendation, the manufacturing method, material, okay, volume, mass, etc. So you can sort. So here I am sort this design by mass. So I will click this mass. Okay. So when I sort, when I click this sort by mass, what happens? This first design will be the this first design. Here you can see structural study, outcome 7, and here you can see what is the mass, 1.592 pound mass. Okay, and I will go to the last option. Here you can see structural study, outcome 1. What is the mass? 3.806 pound mass. That means here you can see this is the lightest. This is the lightest design, that is 1.592 pound mass, and this is the heaviest, 3.806 pound mass. Okay, so in this way you can sort by various options. So this is, and also here you can see in the left side there is a slider. Okay, if see here you can see mass. What is the mass? Lightest is 1.592, and what is the heaviest? 3.806. If you want to filter this, you can filter. Say I will move this. Here you can see this is 3.59, outcome 3, and this is 3.806. Or you can, if you want to change this filtering like this, here you can see this is the outcome 7, 6, 5, and 8, lightest 1.592. So here in this section the heaviest will be 1.732. Okay, or you can, okay, or you can filter like this. Okay, so 2.87, 2.59. Okay, so in this way you can, you can sort by various options. Okay, so I will click, so I will select any one. Say I will select, see here you can see this is outcome 9. Okay, so I will double click this. So I will double click this. What happens? So you can see the design 9. So this is my outcome 9. Here you can see this is my outcome 9, and this is my outcome. Okay, this is the generative design. Okay, outcome 9. Here you can see preserve geometries. There is no change. These 4 bodies and these 2 rings. Any change? No, there is no change. That means these 6 geometries are preserved. That means preserve geometries. All other geometries, that is called the obstacle geometry. So these 6 are the preserved geometry. There is no change while generating the design. That is called preserved geometry. So this is my outcome 9. Okay. If you want to create, you can click this create and click this design from outcome. Okay. Then here in the bottom you can see various iterations. So here this is iteration 25. That is the final iteration. If you want to change this iteration, so here just move this. You can see the iteration 18. Okay, so this is the iteration 80. Okay, so again, once again, I will go back to iteration 25. Okay, if you want to click this finish, okay, you can finish this. Okay, say the first, the lightest one. Okay, 1.59. I will double click this. This is the lightest. Okay, so this is the lightest one. And here in the right side, you can see the properties. See what is the mass, 1.590. So here you can see the mass 1.590. So here, if you want to see the model, you can click the model view or transparent view or stress view. Okay, low stress, ideal and high, you can see. Then this design preview. Okay, if you want to show the preserve geometry view or obstacle geometry view, click this preserve geometry. You can see green color, these 4 bodies plus 2 rings. This represents the preserve geometry. If you want to see the obstacle geometry, so this is the obstacle geometry, and this is called design space. This preserve geometry as well as this obstacle geometry, this is called a design space. Okay, so again I will okay, again I will go to finish outcome. Okay, so again you can see the thumbnail. Okay, so these are the generative designs. So you can explore. Okay, you can explore, and you can explore all these designs, and you can select the optimum one for the for final manufacture. Okay, so if you want to sort using the maximum displacement global, so click here maximum displacement global, and here you can see this. Here this displacement will be 0.01 inches, and this is 0.02 inches. Again, this is the lowest displacement, and this is the highest displacement. Okay, in this way you can sort using this option, or you can use this filtering option also. Okay, you can use this filtering option also. Okay, then if you want to compare, say for example, if you want to compare any four generative designs. Okay, say for example, if you want to compare, say say 10. Okay, so you have to select this. Okay, here you can see a small box, you just click here. Okay, so that means this outcome 10 is selected. Then I will select, say, another outcome. Okay, I want to compare, say 9. Okay, this is another outcome. Then I will say select 11, and say another one, say 15. Okay, so I have selected 4 outcomes. I want to compare these 4 outcomes. Okay, so in the bottom you can see 2 circles. That means open the comparison view. Okay, just click here. That means that 4 generative designs will be displayed here in this screen. Okay, so here you can see the outcomes. Okay, so I have selected outcomes 9. So here this is 9, outcome 9. Here outcome 10, then outcome 11, and outcome 15. So here you can see these are the 4 outcomes. So you can compare this 4 outcomes, outcome 9, 10, 11, and 15. Okay. Okay, when you click this, you can see the properties, outcome 15 properties displayed in here. See, check what is the mass, 2.05. Okay, so here what is the mass, 3.118. So here the mass will be 2.953, and here this mass will be 2.87. Okay, in this way you can compare various designs. If you want to remove one design and add one design into here, okay, so what is the step? Okay, so click here and click this button. Okay, then go to compare. Okay, then I will select number 3, outcome 3. Yeah, so here you can see, I have removed, say, number 15, and I have added outcome 3. Now you can see outcome 3, outcome 9, outcome 10, and outcome 11. I have removed outcome 15. So you can compare. Okay, so you can compare your various designs like this. Okay, once it is completed, you can click this finish outcome view. Okay, then this scatter plot view. Okay, so this is the scatter plot view. So here I will change this into, say, maximum displacement global, and here the volume. Okay, so here, okay, you will get a scatter plot. Okay, like this. Then another one is properties view. Okay, you will get the result. You will get the generative design with their properties. Okay, and finally this table view. Okay, you can see like a table like. Okay, so you can export. Okay, so I will go with this downloads. Downloads, then explore. Okay, so you will get an Excel file. Okay. Okay. So this is an example of a bracket example in generative design. So once again, this is the advantage of this generative design. Okay, so you can define a design problem. You can define a design problem. You can give your constraints. You can give your goals. So based on your goals, constraints, this you will get a set of designs. So these are the set of designs. Okay, various these are these. What is the speciality of these designs? All these designs are satisfying your goals, your constraints. Okay, all these designs are actually satisfying your goals, your constraints, etc. So these are the set of the designs. So you just explore all these set of designs, and you can select the optimum one for manufacturing purpose. Okay, so in the next video I will explain another example, that is the, okay, I will click this finish explore, then I will explain the next example, that is ALCOA bracket. That is the second example. Okay, so you have to practice this, you have to go through this, you have to practice this, and next video I will next session I will give you an idea about this ALCOA bracket. Okay, so thank you very much.